This is celestial navigation on a flat Earth using an AE map. And spoiler alert, our location wound up being Quito, Ecuador. This is not part of the celestial navigation process yet, but I wanted to give people who've never seen this before something to reference so they can see what's going on. I'm going to be using the AE map generator. It's at ns6t.net. Tom put this thing together and did the transforms, made the algorithm to make it easy for everybody. So thanks, Tom. Before we get into the celestial navigation, I just wanted to say a couple things about this dual pole model for a flat Earth. It starts off with the sun over Tropic of Cancer, and then it shows the opposite star rotation. Then it shifts. It's usually gradual, but it'll shift to the equinox, and it makes the long straight path over the equator. And then it shifts to the south over the Tropic of Capricorn. But if you pay attention, you can kind of see the right after equinox where the sun kind of jumps to the south in real life. The problems would arise going south from Hawaii, but it just so happens that that part of Antarctica is unclaimed. There's so many just so happens, like it just so happens the shipping containers don't take the Pacific. It just so happens planes don't fly over the Pacific to go from the west coast of the U.S. to like Asia. It just so happens that's where the time zones are messed up. It just so happens that's where Amelia Earhart came up missing. It just so happens that's where other major plane flights have disappeared. So there's so much wrong with that area. But this is the Vandy Globe on screen, the path. They call it the race around Antarctica, but it never even drops beneath the 60th south latitude. There's so much more wrong with this area I'll go over in future videos. But having said all that, I mean, I'm not going to fight over this model. I'm not glued to it. I just, I will discuss it with people. But, and I thought it was pretty interesting. I figured I'd share it. I like any ideas. The Globers act like it's impossible to have two poles, two star rotations on a flat Earth. Well, there's your possibility. Let's quit acting like things are impossible. So without any further ados or further adoings, let's get into the cell nav. So I've got Quito in the middle for people who are new to this that have a location to reference. Okay, so I've got to do a crash course. So normally the GP of the star, the ground position of the star directly above, goes right there in that spot. And however many degrees your measured angle is to that star, you subtract from 90 and multiply times 60 nautical miles to get your circle of equal altitude. That is a flat plane circle of equal distance. So here's the first star's GP. It's 40 south latitude and 78.3 west longitude. So there a 50-degree angle is measured from the horizon. And so we subtracted 50 from 90 and got 40 degrees. And I just did statute miles because I had to convert it to kilometers. So the circle of equal elevations radius is 4,450 miles, and Quito falls right on it. So you see where I put in for the distance 4,450 kilometers, okay? And I'm pointing out the circle of equal altitude, and there it is zoomed in. That's exactly where Quito is. Really, you only need one GP of a star in a direction on a flat Earth. It's a lot easier. I almost failed to mention that when you measure your angle, you measure it to known navigational stars, and you have to refer to the almanac. And there is a little process. You can go back, scroll to some of my older videos to see celestial navigation on a flat Earth to see the process. But you can use the Haber-Sign formula with the 3 GPs. It's the same as a globe. It's egocentric, meaning it's centered around the person or the observer. What they do is they take it down to an egocentric position on a flat plane in the center of their globe. The math does not work from the surface of their sphere. I repeat, the math does not work from the surface of their sphere. It's the same identical math from an egocentric position on a flat plane projecting up to the celestial hemisphere. The only difference is on a flat Earth it's real. You do the calculations from where you took the measurements from on that horizontal plane. So for the Globers, all 3 of their measured angles all have a common baseline, a horizontal plane they share. If they didn't have the common horizontal plane, they couldn't use the Haversine formula. And if you go 69 miles and get a 1 degree change in a star above you, you get a triangulated height to that star of 3958.7 or 3959. Okay, that is planar trigonometry. That is not spherical mathematics. That is planar trigonometry. There's no flat planes in spherical geometry. Spherical geometry never leaves the surface of a sphere, ever. So now we've cleared all that up. Let's jump right back into it. What happens if we add distance to the circle of equal altitude? So we go from 4450 to 4500 kilometers. And what happens is Quito falls 50 miles inside of the circle of equal altitude. Now we will move on to measurement 2. So 31 degrees is our co-altitude, meaning we measured a 59 degree angle. Subtracted from 90 is 31. So we multiply that times 69 statute miles and then multiply that times 1.61 to convert to kilometers. So 3,443 kilometers is going to be the radius of our circle of equal altitude. Next, we refer back to the almanac to get the ground position directly underneath that star on Earth. And the ground position is 31.1 degrees north, 78.3 degrees west longitude. So as you can see on screen, that is what I entered, and let's see our position in our 3,443 kilometer circle of equal altitude. So you see that the GP is right off the coast of Florida. Hey, wait a minute. That's right down the road from my house. I was surfing there yesterday. No, I'm just kidding. You see that the circle of equal altitude falls right on Quito as expected. So I zoom in a little bit to give you a better look, and right where you see the flag from Ecuador is right there at Quito. So would that be Ecuadorian flag or Ekish flag or Equloc? Equinese perhaps? Eki? Ecuadorker? Ecuadorian? Ecuadorican? Ecuadashian? Ecuadorian. Enough with the games, Brian. Okay, this is the GP to the third star, and it is 0.1 degrees south latitude and 38.3 degrees west longitude. So we generate our map with said coordinates and a 4,450 kilometer circle of equal altitude and see what we get. So I'm going to make a wild, reckless prediction that it falls right on Quito, Ecuador. So let's zoom it on in and show everybody ain't no funny business going on here. And I just thought this was hilarious. It says Ito. It literally split Quito in half. So it did land right on Quito. So there you have it, folks. You can overlay the three. You could just use the one. You could use the Haversine to get distances and azimuths. So Roohif, I will be expecting payment. I'll send you a Cash App link, but I will probably give you a couple more examples first.